Alright, so for this next, the rest of them on this page, do the math for NO2 -1. Find that we need 3 bonds, so that means we've got our nitrogen in the middle surrounded by oxygens, one of which has to be a double bond. Don't forget that it's a charge. Our ABE notation, A for our central atom, B, it's bound to 2 different elements, or 2 different atoms, I should say. And then E, because we've got a pair of electrons that aren't part of the bond. That corresponds to Bet. The only bonds that we have in this compound are nitrogen to oxygen. Find the difference in electronegativity. We end up with 0.5. That tells us the bonds are polar, but may or may not be a polar molecule, so we have to run through the flow chart. And it turns out that it's polar because of these lone pair of electrons up here. So we go down to the next one, CH4. We're going to need 4 bonds, our carbon in the middle, hydrogens around it, 4 bonds connecting them, so we used up all of our bonds. Our ABE notation, AB4, so there's 4 atoms that connected to the carbon, no lone pairs on the carbons, so we're good there. That corresponds to tetrahedral. The only type of bonds that we have are carbon to hydrogen. Find the difference of electronegativity, and it's 0.4, so this compound is nonpolar. There's nonpolar bonds. There are no polar bonds in this, so that means that the whole molecule is nonpolar. Here, CO2, we've got 4 bonds. We've got a carbon in the middle, flanked by the 2 oxygens. Throwing double bonds in there to give up our total of 4 bonds here. No extra electrons around our carbon. Corresponds to AB2, which, if we look up the shape, is linear. The bond between carbon and oxygen has a difference of electronegativity of 1. That's going to give it a polar nature. But the molecule itself is nonpolar because there are no lone pairs on our central carbon. If we follow that flow chart, we'll end up in nonpolarville. There's a correction. I don't know if I told you guys or not, but B is not happy with 2 valence electrons, but with 6 valence electrons. So we do the math. We should end up with 3 bonds. Boron to the 3 fluorines, that's going to give us AB3, no extra electrons for boron because it's going to get its 6 that it's happy with there. That corresponds to trigonal planar. If we do the difference in electronegativity, it's actually 2, so anything above, I think in our notes, 1.7 is going to be ionic, so we don't even have to enter that flow chart because there are no polar bonds, so it just would be ionic. Our second to last one, H2O. We're going to need 2 bonds, our oxygen in the middle, 2 hydrogens, 1 on each side. And then to make the oxygen happy, we're going to have these 2 pairs of electrons hanging out the top and the bottom. Our ABE notation is going to be AB2E2. That's going to correspond to the bent shape. The only bonds that we have are oxygen to hydrogen. Oxygen's got a 3.5 electronegativity, hydrogen's got a 2.1. Do the difference, that's going to give us 1.4. That's going to correspond to a polar bond. If we go through the flow chart, it's going to be polar because the molecule is going to be polar because of these pairs of electrons that are hanging off the top. Then if we go down to the last one on this front page, we're going to need 4 bonds. Oxygen will be in the center because generally halogens only going to be wanting 1 bond to make them happy. They only need 1 electron to fill up their outer shell, so they can get that from just 1 bond. So oxygen in the middle, we've got oxygen to fluorine, oxygen to bromine, and oxygen to each of those other oxygens. That's going to give us an AB4, which is also tetrahedral. Now for our polarity, this is where it's going to get tricky. We have 3 different types of bonds. We've got bonds that connect our oxygen to our oxygen to our fluorine, and our oxygen to our bromine. So we have to do the electronegativity differences for each of those. So we find that our oxygen-fluorine bond is polar, our oxygen to oxygen bond is nonpolar, and our oxygen to bromine bond is polar. So we flood that into the flow chart, and we find out that this molecule itself is polar. So that's it for this first page. I'll do the same thing that I just did on this video for the questions on the back page.